AI system PanEcho achieves 91% accuracy in echocardiogram interpretation. Latest JAMA study. Imagine a world where artificial intelligence can accurately interpret echocardiograms, potentially revolutionizing cardiac care. A recent study published in JAMA has unveiled that an AI system demonstrates remarkable reliability in interpreting echocardiograms with impressive accuracy, regardless of geographic location or the time frame in which the data was collected. This AI technology, if integrated into echocardiography labs or utilized as a screening tool in point-of-care settings, could significantly enhance diagnostic processes, although it still requires thorough evaluation in real clinical environments. The research was led by Gregory H. and his team. The PanEcho AI model was developed using transthoracic echocardiographic TTE data collected from routine clinical practices at the Yale New Haven Health System, YNHHS, between January 2016 and June 2022. The training dataset comprised a staggering 1.2 million echocardiographic videos, which were sourced from 32,265 TTE examinations involving 24,405 patients. To ensure the model's reliability, internal validation was conducted using a separate cohort from YNHHS during the latter half of 2022. Additionally, the model underwent external validation across 4 different healthcare cohorts and was made publicly available for broader evaluation. The training process utilized a multitask deep learning model capable of simultaneously handling both diagnostic classification and the estimation of echocardiographic parameters. The performance of the PanEcho model was evaluated using 2 primary metrics. Area under the receiver operating characteristic curve, AUC. This metric was used for assessing diagnostic classification accuracy. Mean absolute error, MAE. This metric was employed for estimating echocardiographic parameters. Key findings. Diagnostic accuracy. In internal validation, PanEcho successfully completed 18 diagnostic classification tasks, achieving a median AUC of 0.91 with an interquartile range IQR of 0.88 to 0.93, parameter estimation. For 21 echocardiographic measurements, the median normalized mean absolute error was recorded at 0.13, IQR 0.10 to 0.18. The estimation of left ventricular ejection fraction, LVEF, showed a mean absolute error of 4.2% in internal validation and 4.5% in external validation. The model demonstrated an AUC of 0.98 internal and 0.99 external for detecting moderate or greater left ventricular systolic dysfunction. For right ventricular systolic dysfunction, the AUC was 0.93 internal and 0.94 external. Severe aortic stenosis detection yielded an AUC of 0.98 internal and a perfect 1.00 external. Performance in limited protocols. In an abbreviated TTE cohort, the model handled 15 diagnostic tasks with a median AUC of 0.91, IQR 0.87 to 0.94. In an emergency department point-of-care cohort, it managed 14 diagnostic tasks, achieving a median AUC of 0.85. IQR 0.77 to 0.87. In summary, this study highlights that the PanEcho AI model is capable of accurately interpreting a wide array of echocardiographic parameters and diagnostic labels with high precision across various real-world clinical settings. These findings support the potential for integrating PanEcho into standard cardiovascular imaging practices, particularly as a means to improve efficiency and consistency in echocardiogram reporting. Reference: Holstay G, Oikonomu EK, Tokodium, Kovakiev, Wang Z, Kara R. Complete AI-enabled echocardiographic interpretation with multitask deep learning. JAMA 2025 334 318. Johnson K and TLO.co/0001 on 10.3. About the authors. Dr. Ria Days graduated from Gujarat University with a degree in dentistry in 2022. She is a dedicated dentist and a skilled medical and scientific writer, known for her passion for making clinical knowledge accessible for the public. Dr. Dave actively contributes to health and wellness blogs. Dr. Kamalkad Kohli, an MBBS and DTCD chest specialist with over 30 years of experience, has a talent for writing clinical articles. He serves as the chief editor of medical news at Medical Dialogues. In addition to writing, he meticulously proofreads, then verifies all medical content published by Medical Dialogues, including articles derived from journals, studies, medical conferences, and guidelines. You can reach him at Dr. Cully at medicaldialogues.in or contact him at 011 437 28751.